Section 1.2. Number sets and negative numbers in the real world. So one of the last Karate Kid arithmetic concepts that we do need to go over is the concept of negative numbers. Negative numbers are woven into the fabric of every algebraic problem we will see. Okay? And we have to be able to efficiently deal with negative numbers. So first we need to discuss the different number sets that exist, just to be somewhat familiar with them. And so if you look at your workbook, the first number set is called natural numbers. So underneath natural numbers, you can write the example of what they are. The natural number set starts with the number 1, then does 2, then does 3, and goes on forever and ever and ever. Okay? That's natural numbers. And we can remember this. They're also sometimes called the counting numbers. And what comes naturally when we count? Do we start with number 1, say 1, 2, 3, or do we say 0? 0, 1, 2, 3. What do we do? 1. Yeah, we always start with number 1. So that's the natural numbers. The whole numbers start with the number 0, 1, 2, 3, and go on forever and ever and ever. So the only difference between the natural number set and the whole number set is what?
0.
It's just 0. That's it. Okay? And then the integers. Okay? So this is natty, and this is whole, and this is integers. So integers, dot, 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 negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, dot, dot. So this incorporates what? Negatives. Very good. And they're all negative whole numbers. There's still no fractions, no decimals. It's all whole number values. We have negatives and positives. Cool? The next number set up here is what we call rational numbers. And rational numbers, okay, they include, ready for this? Dot, 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 negative 15 over 2. Dot, 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 negative 2.7. Dot, 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 negative 1. Dot, 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 0. Dot, 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 1.33 with a bar over it. Dot, 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 what do we got here? 7 over 2. Dot, dot, dot. 14, etc., 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 dot, dot, dot. So what we're saying here is, now the rational numbers, they include decimals and fractions. So I'm going to ask you a question or two, and I want you to answer these rapidly and succinctly. Here we go. Are natural numbers rational numbers?
Yeah.
Yes. Every number in that set is included in the rational number set. Okay? Are all rational numbers natural numbers? No. Are whole numbers rational numbers? Yes. Are integers rational numbers? Yes. Are whole numbers integers? Yes, they are. You ever seen the Russian nesting dolls? You ever seen those? You know, like one doll fits in the next and the next. That's how these number sets work. All of these fit into the one below it, okay? But are all integers natural numbers? No. But all natural numbers are integers. All whole numbers are integers. We cool? Okay. So, our Heavenly Father has taught us that in all things there is an opposition. So if there are rational numbers, there are irrational numbers. And I want you to write down 2 things that make something an irrational number. 1, it is a forever number. I mean, it means it goes on forever and ever and ever and ever and ever. And 2, it's unpredictable. But you have to understand something. You have to be both of these to be an irrational number. Think of an irrational person. You know, can you predict their behavior? No, usually not. So some examples of irrational numbers. Okay? I want to ask you, pi. Pi is an irrational number. 3.14. Put pi in your calculator. Really go. Go. Put pi in your calculator. Enter it. What does it say? 3.14. Keep going.
15926.
Etc., etc., etc. Okay? And that number goes on forever and ever and ever. So it's a forever number, but you can't predict what number comes next. Ready for this? What about 2.333 with a bar over it? Is that irrational or rational?
Rational.
It's rational because It's predictable. Very good. So that's why 1.33 is over here. So is anything else with a bar over it. You know what it's going to be. The square root of 5. Put the square root of 5 in your calculator. You're going to get 2.2 something. What? What do you get? Okay, and it goes on forever and ever and ever and ever. Okay? All imperfect square roots are irrational numbers. Combined, the rational numbers and irrational make the universe of all real numbers. Okay? So all of these constitute all real numbers. Well, if Heavenly Father said there's an opposition to all things, if there are real numbers, there are fake numbers, and we use the word, instead of fake, they're called, in algebra, they're called imaginary numbers. We're not going to talk about that because this is beginning algebra and that's an advanced topic. So we're just going to stick with real numbers. Go? You cool? All right. All right. We asked these questions that are down at the bottom here. Okay? We asked these questions. Are natural numbers whole numbers? Yes. Yes, they are. Are all whole numbers natural numbers? No. Are natural numbers and whole numbers integers? Yes. Are all integers whole or natural numbers? No. Are all negative numbers integers? No. Fractions and decimals. Fractions and decimals. Is 2.3 with a bar over it a rational or irrational number? Why? Predictable. If there's an opposition in all things, what's the opposite of a real number? We said it, imaginary. All right, cool. All right. There are a couple other concepts that we want to do. So in your homework tonight, you're going to see some problems like this right here that I've got highlighted in blue. I'm going to take it off. So let's do this really quick. It says, state the real numbers that correspond to the situation. And you're going to be blown away at how simplistic these answers are. But what they're doing is they're helping you differentiate between positive and negative numbers in the real world. So when we're doing word problems, we can apply, is the number negative or is it positive? Okay? So in February, I had a $5,800 debit on my bank account. By May, my balance was $15,000 credit. State the real numbers that correspond to the situation. Okay? So I'm going to help you with this first one. The first one is $5,800, and the second one, a debit, so that's negative $5,800, and the second one is positive $15,000. And we don't write plus in front of a positive number, do we? We just write the number. We good? So that's negative, and that's positive. Cool? Okay. In Israel, we visited the Dead Sea at 1,414 feet below sea level. What's that going to be? Negative 1,414 feet. Okay? And then hiked Mount Tabor at 1,886 feet. So that's going to be what? It's just positive 1,886 feet. Pretty easy, pretty simple stuff. Cool? Okay, let's go to our next one. Sorry. Graphing numbers on a number line. Again, this section, super easy stuff. We're just getting the very basics of negative numbers and how they function in math with us. If I tell you to graph a number on a number line, okay, you're going to have to draw a number line. It's not super hard. Just draw a line. Okay, so we could take, for instance, right here, put an arrow here, put an arrow here, 0 in the middle, 1, 2, 3, 4, 1, 2, 3, 4. This is positive 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. They ask us to graph negative 12/5. Well, it might be helpful to divide this on a calculator and see that this is negative 2.4. And it sits about right here. You know, and a number line is kind of a estimation, right? You're putting the dot where you think it needs to be. And so, but you are to label that. So you're going to say that's negative 12 fifths, and you put it right there. Okay? You'll draw another number line for negative 4.8. Okay, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5. And you can say negative 4.8 is right there, negative 4.8. And it's good to label these 1, negative 1, positive 1, and stuff like that, right? 2 2/3. How about we put this on this one, just to interest of time here. 2 2/3 right here, 2 2/3. Pretty easy stuff, agreed? Just putting the numbers where they belong on the number line, positive and negative. Conversions. One of the things we want you to understand is when we make conversions from fraction to decimal, decimal to percent, things like that, signs are constant. So if you're positive to begin with, you're positive to end with. If you're negative to begin with, you're negative to end with. So if I have you convert negative 5/8 and I say, hey, convert that fraction to a decimal, negative 5/8, what do? We divide on a calculator. So we go ahead and do that, divide that, and you get negative 0.625. Agreed? Yes or no? Look at your calculators. Did you get it right? Okay, but it was negative to begin with. The negative is a constant. The negative stays over there. So let's go ahead and convert 5/6. Do 5 divided by 6 on a calculator. What do you get? Say it loud. 0.83 repeating. Very good. 0.83 repeating. And it's positive because the fraction was positive to begin with. Negative 7/6. Go ahead. Negative 7/6. Go ahead and divide that on a calculator. You get negative 1.16 repeating forever and ever and ever. And again, negative, negative, positive, positive, negative, negative, right? Okay, let's go to the next page. You see how there's not a lot of work to show? You see how this is pretty easy? Inequality signs. An inequality sign, whenever we put the word in front of something, it means not. So literally translated, inequality means not equal. Inequality sign means it's not an equal sign. We read these from left to right. Okay, to show you this really quick. This means more than. Agreed? Keep losing these erasers. Keep bringing it over there. Okay? This means less than. This means more than or equal to. This means less than or equal to. Why does this mean more than? Well, if we read from left to right, the open side is always the more than side. The closed side is always the less than side. So this is closed, so it is less than. Why is this more than or equal to? Well, open side, more than, and the line means or equal to. So this is more than or equal to. Right? And this one is going to be what? Less than or equal to, because it's closed on that side and it has the line. So it's less than or equal to. Okay? Questions. Here we go. We either want to use less than or more than in between these boxes. Let's look at this really quick here. Is negative 54 more than or less than negative 5? Less than. Do you see what we're trying to catch you on there? 54 is more than 5. But a negative value, let's look on the number line here. The further we go this way, the less the value. So this is negative 5, and we keep on going down here, and all the way here we have negative 54, right? Negative 54 is way down there. It's less than negative 5. Negative 8, what is it? Less than or more than 8? Less than. Negative 10, less than or more than negative 14? More than. Very good. Does a larger negative number have greater value? No, it has less value. True or false? Look at these ones. These ones catch people a lot. Is negative 5 less than or equal to negative 5? True or false? True. I get students like, no, Brother Rich, it's not less than. Yeah, but it is or equal. This is a less than or equal to statement. It has to be one or the other. If it's equal to, it makes it a true statement. Negative 5 is equal to negative 5. This is a less than or equal to statement. It doesn't say less than and equal to. It says less than or equal to, right? Is 0 more than or equal to 7? That's false. Negative 3 is more than or equal to negative 8. True. Very good. Okay, let's go further on down here. Write an inequality with the same meaning. Negative 5 is more than x. I'm going to help you do this first one. Negative 5 is more than x. Really interesting here. We read from left to right, but if we read backwards, x is on the more than or less than side. So x is less than negative 5. These two are the same statement. Okay? So let's do the next one together. X is less than or equal to 12. So what's the other statement? 12 is greater than or equal to x, right? 12 is greater than or equal to x. 12 is greater than or equal to x. Next one, negative 10 is less than or equal to y. What are we going to write? Y is greater than or equal to negative 10. Y is greater than or equal to negative 10. Again, all this stuff, hard or easy? It's pretty fetching easy. Last concept. It's the concept of absolute value. Okay? Absolute value, do you know what the absolute value symbol is? Yeah, it's 2 bars. Look at me. Usually they can be written as parallel lines, slanted, or they can be written vertically as parallel lines. I like to do mine slanted so that they don't look like a wide number 11. You get what I'm saying? But a lot of textbooks go vertical, and so we went vertical here. Okay? What do absolute value bars do? Do you know? What do they do to a number? If I ask for the absolute value of negative 7, what's the answer?
7.
The answer is 7. What's the absolute value of 7?
7.
Is also 7. So what do? They make things positive. They don't make things opposite. If they made it opposite, this would be what? This would be negative 7. So they do not make things opposite. That's worth writing down. They make things positive. And if we're already positive, we stay positive. And if we're negative, we become positive. All right, so let's quickly do these 4 problems. I'm not going to write anything on the board. You guys are going to do this. We did this already. Absolute value negative 7 equals?
7.
Absolute value 7 equals? Absolute value 0 equals? Absolute value of negative 30.5 is 30.5. Okay, that is everything. We can go ahead and end the video.